Hello again, my personal finance and financial management students. For better understanding, make sure to watch video number 1 and number 2 of course packet 3. We will now discuss the compound amount formula or the short method of computing for the compound amount. We will use the same example about Alda Aldora. 5,000 is our passbook savings account, 10% is the interest, and the interest will be compounded semi-annually for 2 years. So 10% is the interest per year, and since the interest is compounded semi-annually, every 6 months, the interest will not be 10%, but it will just be 5% only. So if you go back to video number 2, the original principal of 5,000 pesos became 6,077.54 after 2 years. So we computed the interest 4 times. Because the interest is compounded semi-annually, the term is 2 years, so every 6 months, in a matter of 2 years, that would be all 4 times. So 4 compounding periods, or 4 times the interest will be added, 4 times the interest will be charged. But what if the interest compounding period is monthly? So that would mean 12 times in a year. So for 2 years, that would be all in all 24. So imagine how long the computation would be if we're going to use the manual calculation or the long method. But there is a remedy for that. The compound amount formula or the short method. The compound amount formula will make use of the following symbols. So we have A, which represents the compound amount or the future value or the maturity value, or it is actually the sum of the principal and the accumulated interest. P represents the present value or the principal. Then 1 here is constant. I represents the interest rate per period expressed as decimals. So let us say, for example, on our previous illustration, 10% is the interest per annum, but every 6 months, the interest will just be 5%, and that represents the I. And then we have the total number of compounding periods, means the number of times the interest will be computed or compounded for the entire term. On our previous illustration again, 2 years, twice in a year, so that means the total compounding periods will be all in all 4. The compound amount formula will make use of the value of I and the value of N. So the first thing you have to do, of course, is to identify the given. So if we are computing for the compound amount, what will be given is the present value or the principal. Then we'll be having the annual interest rate, but that annual interest rate must be converted into interest rate per period by getting the nominal rate or the annual rate or the interest rate per year and divide it by the number of compounding periods per year. That is how you will get the value of I. And to get the value of N, or the total number of compounding periods for the entire term, you have the number of years, or the time, or the term given, multiplied by the number of compounding periods per year. So what you divide here is the one that you're going to multiply here in finding for the value of N. So let us say, for example, if it is compounded semi-annually, that means twice a year. So you divide it by 2 here and you multiply it by 2 when you will be computing for the value of N. So this chart will help you determine the value of our periods per year. So this was discussed also in our previous video, but again, if the interest is compounded annually, so that means the periods per year, or the number of compounding periods in a year, is equal to 1. And then if it is semi-annually, it is equal to 2, quarterly 4 or 4 times in a year, and then monthly 12, and daily 365. So these compounding periods per year will be the one to be used for our value of I and value of N. So here we need the periods per year. Here we need the periods per year. You're going to take it from this chart. That is the periods per year. So with regards to our example, our nominal rate or our annual rate is 10%, and the periods per year, since it is semi-annually, is 2. We have the interest rate per period, or the value of I, as 5%. And the total number of compounding periods would be 2 years times the number of periods per year, which is 2, is equal to 4. Again, what you use here, the periods you use here, will be the period that you're going to use in computing for the value of N. So with that, we have already the value of I and the value of N. And afterwards, we could now proceed with our formula by substituting what we have computed with the given formula. We have 5,000 as the P, 1 is constant, I is 0.05, and N is equal to 4. So using your calculator, 1.05 raised to 4, we have 1.2155. So we have compound amount as 6,077.53. So to get again the compound interest, 5,000 principal will be deducted from 6,077.53. So using the long method and the short method, we have the same amount of compound amount and the same amount of compound interest. So this value of A again will be the maturity value, which represents already the sum of the principal and the accumulated interest. So again, we're not going to go with this long method if we know how to use the compound amount formula. But as you can see, whether you use the formula or the long method, we're going to arrive at the same amount of compound amount, future value, or maturity value. So what if what is being asked is the present value? So if the present value is being asked, that means what was given to us is the future value or the maturity value. If you are asked how much must you deposit now, how much must you invest now, what is the principal, what is the present value? So this will be the formula that you're going to use. So from our compound interest formula, we will just derive the present value formula. So here, we multiply P with the value of 1 plus I raised to N. But now, since we will be computing for the principal or the present value, so we're going to have A as the given or the future value or the compound amount and divide it by 1 plus I raised to N. So these two will have the same amount, 1 plus I raised to N, but the operation now it will become division. And another formula which was derived also from this formula is that A will be multiplied by 1 plus I raised to negative N. So if you will be using the second formula, take note that N will be a negative 1. So Let us have again the same example, 5,000, 10%, and 2 years, compounded semi-annually. If you are asked to compute for the future value or maturity value, you will arrive at 6,077.53. So what if what was given to us is the compound amount or the future value, and we are required to compute for the present value? So get now the given future value or compound amount and divide it by 1 plus I raised to n. So again, you have to compute first for the value of I and the value of n. I will be computed by dividing the nominal or the annual rate with the number of periods, and n could be derived by multiplying the number of years with the number of compounding periods. So using the first formula, our present value is 5,000 pesos. That if you're going to check it with our first computation, it's the same, 5,000. And then on our second formula, given the future value or compound amount of 6,077, let us see if we could able to arrive at 5,000 pesos. 1 is constant, I is 0.05, and again, n would be negative. So 1.05 raised to n is equal to 0.8227. So we call this as the present value factor. You multiply the present value factor, or 1.05 raised to negative 4, the amount that you're going to derive from it, with the future amount, that will give us the present value. So whether you use the second formula or the first formula, we will arrive at the same amount of present value, which is 5,000 pesos. Okay, so remember class, that in every investment, we have to consider the future value and the present value. So if you're not going to consider the time value of money, we will going to look at the amount that we will be receiving as the same amount. But if you're going to analyze it deeper, its present value will be different from its future amount. Okay? So that ends our discussion for course packet 3. So I hope you could able to answer now all the requirements, all the activities on our module. Thank you very much for watching. Again, make sure you had able to watch the 3 videos that I had posted.